All right, so now that we've covered everything you need to know about how to find circumference, how to find the arc, which is part of the circumference, and how to find, if you're given the arc and the central angle, how to find the circumference or the radius. Or if you're given the arc and the radius, how to find the central angle. All right, so all those things we've been focused on the circumference of the circle. That's really just the perimeter. So what we're moving on to, and this is on page 4 of that set of notes you had. We just finished looking at page 3, page 2, and page 1. Now moving on to page 4, you see that the focus is shifting away from the circumference of the circle, away from the perimeter, and it's focusing on the area of the disk. You'll hear me talking about the area of the circle. Really, I should formally be saying the area of the disk, which, like I said, that's the inside of the circle is the disk. But in practice, we all just kind of say circle because we know what we mean. If you're asked for a definition, then remember, then it'll be important. But if you're referring to the area of the inside of the circle, then that's good enough. Okay. So the area inside of the circle, we already saw that formula a while ago. It's pi r squared. And the reason why it's pi r squared is, let me just show you this a little bit. The reason why it's pi r squared is because you say to yourself, if I have the radius of a circle like this, and I square that, we saw this with the Pythagorean theorem, when you square the number that's the length of the radius, let's say this radius is 4 centimeters long, then when you square it and you get 16, you get 16 centimeters squared. And I'll show you what that means. You're actually finding out the area of a square. I know this isn't properly a square. Let me fix that. You're actually finding the area of a square that has those side lengths. Okay. And if I have along here, I've got a square that's 4 centimeters long, like this. See if I'm going along here and saying, I've got 1, 2, 3, 4 centimeters. And I got 4 centimeters going down this way, like this. Then the area is, count here, you got 16 squares. So when I square the radius, I'm really finding out how big is a square that has that radius as one side of it. And so I have a square here that's 16 centimeters squared, assuming this radius is 4 centimeters. So this is just r squared. The area here is r squared. To find the area of this whole circle, I could say to myself, well, if I had just this one square, and then I wanted to get the whole area of the circle, well, then it'd be kind of like if I had 4 of these, right? Because this is down here, this is like 1/4 of the circle. But it's not, you notice here, the circle part doesn't take up the whole square. It only takes up a part of it. And the percentage that it takes up is about 77%. Now you may be wondering where I'm getting that number. Let me do a little something off to the side here. If I take, some of you already know what I'm doing with this. The actual percentage is 78.54% if I round it to the 2 closest decimal places. Let me write that here so you can follow what I'm doing. The percent of this square, this 16 centimeter square, that is occupied by the circle is about 78.54%. Okay, that's how much of this square is taken up by this circle. And if I want to get the total area of this circle, then let me take this 16 centimeters squared and multiply it by 78.54%. Okay. Let me do that out here where you can see it. I've got the area of this circle, the area of this square is 16, and I'm going to multiply it by the percent of that square that's taken up by these circles here. You can do this on graph paper and then try and count all the little squares, and if you make it big enough, you should get to pretty close to 78.54%. So I'm multiplying this, clear the memory here. 16, which is the area of my square up here, times 78.54. And then, because it's a percent, I should have divided by 100. So it's 12.57 approximately. That's the area of just this part of the circle here is 12.57 centimeters squared. because that's 78.54% of 16 centimeters squared. But since this is only 1/4 of the circle and I want all 4 quarters, I'm going to multiply that by 4. And that'll give me 50.27. Okay, so I'm going to write that down. 50, the area of the circle, about 50.27 centimeters squared. Okay, I know that 2 should be up higher, but again, I can't really do that here. So what's actually going on here is if I have to take the area of the square, then multiply it by 78.54%, and then multiply that by 4, because there are 4 of them. And what I'm doing is I'm taking my radius squared, which was 16, and I'm multiplying it by 78.54. Now again, you'll see here where that's coming from. I'm multiplying it by 78.54%, so divide that by 100. And then after I multiply it by that, I multiply it again by 4 to get all 4 quarters. And if I multiply it first by 78.54%, and then I multiply that by 4, then really, in sum, what I'm multiplying it by is, what's that? 3.1416. Wait, isn't that? Oh, that's what that is. It's pi. So that's why you get the radius squared, you get the area of the square, and then you multiply it by 78.54% times 4, which is just pi. Get the area of this multiplied by pi, and that will tell you the area of the whole circle. Now, if you find that helpful in terms of understanding why the area is pi r squared, then great. If you don't worry about it. Just make sure you know how to apply the formula. Okay? So let's move on to that. Let's apply some formulas here. I've got a circle. I got a radius of 75 centimeters, and it's asking what is the area of the circle below. So let's round you out to the nearest tenth, but I want you to round it to the nearest hundredth. All right? I like hundredths. It's not more exact. Okay. So I start off. Let me write down my formula. Area equals pi times the radius squared. Okay. Area equals pi times the radius squared. I plug in the numbers that I know here. Well, I know the radius is 75 centimeters, so I can write that right away. Area equals pi times 75 squared. And now's when I break out my calculator. I say, calculator, please tell me 75 squared. I could either just hit the squared button or I could say times 75. Either way would be okay. That's 75 squared, 5625, 5,625. If that's 75 squared, I know I've got to multiply this by pi now to get my area. I get 17,671.46 centimeters squared. So let me write that. 17,000, where's my, oh, here I am. Area equals 17,671.46 centimeters squared. Now, when you're doing this, notice this is a very big number. Makes sense it should be a really big number. But what you want to avoid doing, and this is the single most common error people make when they're first calculating the areas of circles, is, well, sometimes they say instead of r squared, they do 2 times r, which will, if they do pi times 2 times r, they'll just end up getting the circumference, which won't be right. That'll be a much smaller number. But the other thing that they do is they say pi r squared, like it's written here, pi r squared, and they forget their BEDMAS. And they say, okay, if I've got pi times radius squared, they do pi times the radius, and then after they do that, they square it. That's wrong. Do not do that. You always got to say, well, BEDMAS tells me I do exponents, I do the r squared, the squared part of the r squared, before I do anything multiplying, before I multiply pi times that. So I got to do radius squared, then that times pi. All right? So watch out for that. BEDMAS errors. All right, example 1, number B, a little bit more complicated because I've got to find the area. And in order to find the area, I always need the radius. Here, I don't have the radius. But I'm sure you guys have figured out what I have to do here. I got to get the radius based on the information that's here. Say to myself, all right, I know that the diameter is equal to 2 times the radius, right? Diameter equals 2 times the radius. So what do I know here? I know 46 millimeters is the diameter. So let me plug in 46 in the diameter spot. So I've just replaced the d with the 46 because I know that the diameter is 46. And now I want to find the radius, so what do? I got to divide both sides by 2. Fine. And the reason why I do that is because when I divide this side by 2, the 2's cancel out. I'm just left with r right over here. And if I do that on the other side and I do 46 divided by 2, then I don't even need a calculator for that, right? I can just say that that's going to be 23 millimeters. Now, once we have that our radius is 23 millimeters, now we can go on and use this formula here, right? Area is equal to pi r squared. Let me write that formula again over here. Area is equal to pi r squared. So I plug in, now that I know the radius is 23, I can put that in the r spot. I can go right ahead and figure out the area. Area is equal to pi times the radius, which is 23, squared. Oops. Squared like that. That little thing here is just to say that the 2 is up high, since I can't write it on the same line. You'll sometimes see that in some old textbooks. So if the area is equal to pi times 23 squared, then we crack open the calculator. We say, calculator, tell me what 23 squared is. It tells me 529. I like the sound of that. I multiply that by pi, and that gives me a very large number. Once again, these areas can be big numbers. And that's my final answer. 1,661.90. I'm just going to write 9 because the 0 in that decimal place doesn't mean anything. And very important, the units here are not millimeters, sorry, not centimeters, and they're not even millimeters, they're millimeters squared. Never forget to put the right units in here, guys. All right, area is 1,661.9 millimeters squared. Sounds good. I'm done. This one here, C, I'm sure you can figure it out. Do it on your own. You'll see you got to use pretty much the same technique we used here. Just make sure you get all your decimal places, all your units right for that one as well.